Hello, and welcome to our Blossoms module on the flaws of averages. My name is Rhonda Jordan, and I'm a graduate student here at the Massachusetts Institute of Technology in Cambridge, Massachusetts, USA. We begin our module with 2 illustrations of some limitations of averages which helped motivate us to make this module. Our first example is as follows. On Thursday, I performed a modern dance on campus in this white dress. Then, Friday night, I went to MIT's elegant grad gala in my favorite black dress. For Saturday night, I was going dancing with some friends, and I decided to wear something that was the average color of the 2 dresses. So what did I end up wearing? This, which has neither the elegance of the black dress nor the simplicity of the white dress. My friend Dan, who's also a graduate student at MIT, has a quick story about a day he had recently that will help illustrate what we mean by the flaws of averages.
Thanks, Rhonda. Hi, my name is Dan Livengood, and like Rhonda, I'm also a graduate student here at MIT. For our second example, I'd like to tell you a quick story about a day that I had recently. On that day, I spent 4 hours in the morning here at MIT. Then, in the afternoon, I spent 4 hours across the river in downtown Boston. So, if I were to stand at my average location over those 8 hours, where would I be? Yep, I'd be standing on the Charles River. At least there was a sailboat for me to stand on. Hello again. I'm Dan.
And I'm Rhonda. As we said earlier, we are both graduate students at the Massachusetts Institute of Technology in Cambridge, Massachusetts, USA. Today, we're here to talk with you about the flaws of averages.
Now, before we start, we do want to be clear that we're not trying to say that averages are bad. In many situations, averages provide a very good single descriptive number of a situation. For example, what's the average height of all the students in your class?
Exactly. Now, I'm sure that you can come up with a number of other situations where the average number is a good description.
The main point of this Blossoms module is simply to point out a few pitfalls that could arise if you're not attentive to detail when you're using and interpreting averages.
So let's get started and consider a case where the average may not always be a good description of the real situation.
Sounds good.
So Dan, let's imagine that you're at the edge of a river that you want to cross. But there's this sign. The sign says, average river depth 1 meter. Now, given this sign, would you cross the river?
Well, if I saw the sign, I would think, I'm 1.8 meters tall. I'm taller than the average river depth, so I should be able to walk across and keep my head above the water all the way, on average, right?
That's true, if this is your situation. If this is the water, and this is the riverbed, it goes straight across at 1 meter, then you'll definitely be able to keep your head above the water.
Okay, well, I can think of another example where I'd be able to keep my head above the water. So again, if this is your water, and this is your new riverbed shape, if for the first half of the river it's 0.5 meters deep, and then for the second half of the river is 1.5 meters deep, on average, it's still 1 meter deep, with only 1.5 meters as the maximum depth, I'd keep my head above the water.
All right, Dan, but here's the kicker. Let's say this is your waterbed shape. Okay, and you start at 0 meters here, and the riverbed goes all the way down to 2 meters. The average depth is still 1 meter, but in this 2 meter area, if you can't swim, I think you'd have a hard time keeping your head above the water, Dan.
You know, you're right, Rhonda. So, class, what other riverbed shapes can you come up with? And for each one that you come up with, am I going to be able to keep my head above the water if I just decide to walk across the river, especially if I can't swim?
We'll let you guys discuss this with your teacher and your classmates. I hope you had a nice discussion with your teacher about how the average is not always a good description of the actual situation. That is our flaw of averages number 1.
And moving right along, our flaw of averages number 2 is that the function of the average is not necessarily the same as the average of the function.
Dan, what do you mean by that?
Well, Rhonda, it just so happens that I've got a nice little example to help explain this flaw of averages. And I think you're going to like it.
Sounds good.
So I have 2 plates of cookies.
I'm so hungry. Can I have some?
Sure. I'll let you have 1 plate, and then I'll have the other.
Okay, But like I said, I'm really hungry. So can I have the plate that'll fill me up the most?
Sure. What I'll tell you is that underneath A is a plate with 2 circular cookies that have an average diameter of 7 centimeters.
Okay.
And underneath B, there's a plate with 2 circular cookies that have an average diameter of 8 centimeters.
Okay.
So which plate would you like to have?
Oh, Dan, that's easy. I want plate B. The average diameter of those cookies is larger.
Okay. Well, let's look at the 2 cookies that you've just chosen.
Yes.
Now, would you like to see the 2 cookies on plate A?
Sure, why not? Let's see.
Well, here you go. On plate A, you'll see that we have one very large cookie and one very small cookie.
But wait, the area on this plate is larger than the area of cookies on this plate. That's not fair, Dan.
Well, that's exactly the point of this flaw of averages. So, class, do you understand why Rhonda ended up with a plate of smaller area of cookies, even though she picked the plate with the larger diameter on average? Talk this over with your teacher in your class. So far, we've discussed 2 flaws of averages. The first one was that the average is not always a good description of an actual situation. And the second flaw of averages is that the function of the average is not always the same as the average of the function.
Now, the third flaw that we like to introduce is that the average depends on your perspective.
All right, so what do you mean by the average depends on your perspective?
Okay, take me for instance, Dan. So, I'm a dance teacher and I teach 2 dance classes.
Okay.
One beginner's class and one advanced class.
All right.
But my beginner's class has 45 dancers. But my advanced class has 5 dancers. So if we take the average of these 2 numbers, we need to add 45 plus 5 and then divide by 2. We get 25. So, Dan, don't you see how that's 25?
I do see how that's 25.
Okay. So, but what if we actually interview all of the students and ask each one of them, how many dancers are in your class, including yourself? If we take the average of all of their responses, do you think we get the same answer?
Well, yeah, I don't know. I don't see why it would be any different than the 25 that we just calculated.
Dan, I actually did ask all of my students this question.
Wow.
All right. And these are their 50 responses. 45 45s and 5 5s. So I took the average of all of these numbers and I got 41.
Wait a minute. 41? But how is that? Why is that so different than the 25 that we calculated earlier?
Dan, that's exactly and precisely the key lesson of this segment. So class, why is it that when we calculate the average from my perspective, you get 25 dancers? But if you calculate the average from the dancer's perspective, you get 41. Talk this over with your teacher and your classmates. Let's review what we've done today. Our first flaw of averages is that the average is not always a good description of the actual situation.
Our second flaw of averages is that the function of the average is not always the same as the average of the function.
Now our last flaw is that the average depends on your perspective.
Now, these 3 flaws that we've discussed today are not necessarily the only flaws of averages, and we encourage you to look and find other examples where averages can be misleading.
But we wanted you all to have a sense of a few of the pitfalls that might arise if you are not attentive to details when calculating and interpreting averages.
As we leave you today, we have one last example of that first flaw of averages, that the average is not always a good description of the actual situation.
So, in our free time, Dan and I love to perform. I'm a tap dancer.
And I sing.
And so, we're going to put the 2 together for you.
1, 2, 1, 2, 3. Hear the beat of Rhonda's feet to the song we love, the melody of 42nd Street.
Now, if we take the average number of taps that I just tapped,
And take the average note that I just sang,
you'll be listening to the following.
Now, hopefully you agree with us that the first version was much more interesting than the average.
1, 2, 1, 2, 3. Hear the beat of Rhonda's feet to the song we love, the melody of 42nd Street. As we leave you, we hope that you enjoy our song and dance. Thanks for listening to our lesson, The Flaws of Averages. We say goodbye for one last time to the song we love, the melody of 42nd Street.
Hello there. Welcome to our Flaws of Averages Blossoms Modules teacher segment. Rhonda and I had a lot of fun putting this together, and we're glad that you're interested in discussing this with your students. So we wanted to go over a few of the things that we had in mind with the module. To begin with, we mentioned this in the video, and we just want to stress that we're not trying to say that averages are bad. Averages do have their place. At one point we discussed the average height of the students in your classroom. That's just one example of how the averages could be very helpful. But we wanted to go over a few of the pitfalls that you could run into if you're not careful with using averages. So we'll go over each of those three, the flaws of averages that we discussed. And don't forget, you may have other flaws of averages that you've come up with or that you think of that you could go over with your students. So feel free to adjust and adapt this in any way that you find is helpful to explain this to your students. But again, we want to go over some of the things that we had in mind for you to go over in between the different segments. So we'll start off with our flaw of averages number 1, that the average is not always a good description of the actual situation. And we're back to discuss our first flaw of averages, that the average value may not always be a good description of the actual situation. So what did we have in mind with this one? So you may have noticed that there are a few examples along the way to illustrate this point. The two of our opening segments, myself on the river, Rhonda in her dresses, both were designed to help illustrate this point. And we wanted to kind of go over some of the things that we felt that you could talk over with your students after this first segment. So one of the concepts that you could talk about is that the average value may not be an actual outcome of a situation. So what do I mean by that? Let's take this coin here. If I flip a head, I'm going to give you $1. If I flip a tail, I'm going to give you $0. So if I were to flip this coin many times, on average, I'd be giving you 50 cents. Well, wait a minute, but 50 cents is not one of the outcomes. The outcomes were either $1 or $0. So that's conceptually what we were trying to get at with this one. Another concept that you could discuss with your students is that depending on the situation, the average may be exactly the same, but the distribution may be different. So if you have a more advanced class, one of the things we had in mind was you could discuss the normal distribution, exponential distribution, whatever kinds of distributions you want to look at. For example, think of the crossing of the river. We had the flat line, we had the sloped line, we had the sort of double tabletop line. Both of those were essentially 3 different distributions that all had the same average value. So those are the kinds of things that we were thinking you could discuss with your students after this first flaw of averages. You may have some others, and feel free to check out the website. We'll have some more examples of what we had in mind for these. But for now, that's it for this part, and now we'll go on to the second flaw of averages, that the function of the average is not necessarily the same as the average of the function. And now we can talk about our second flaw of averages, that the function of the average is not always the same as the average of the function. So if you've looked at our other segments for the module, you probably remember the example with the cookies. So we had plate A with 2 cookies and plate B with 2 cookies, where the average diameter for plate A of the 2 cookies was 7 centimeters, and the average diameter of the 2 cookies on plate B was 8 centimeters. And as Rhonda helped us beautifully illustrate, intuitively, you would think that the plate B set of cookies would be bigger in terms of area since the diameter is bigger. But as you saw, the cookies on plate A were actually bigger when we uncovered them. So that was just a nice way to illustrate this point that the function of the average is not always the same as the average of the function. Now we've left the math details to a file on the website. So if you're interested in discussing this in further detail with your students, feel free to go look at that page. We've also got another example about wind turbines. And I'm sure you can think of many other examples of functions where, again, the function of the average is different than the average of the function. So we'll now move on to our last flaw of averages, that the average value depends on your perspective. Our last flaw of averages to discuss with you here in the teacher segment is that the average depends on your perspective. So from the main video, our example was Rhonda's dance classes, and we've got a number of other examples on the website that you can look at. I wanted to bring to your attention one of the examples, though, about Lake Wobegon. Now, Lake Wobegon is a fictional town from a radio program here in the United States. And one of the key phrases about Lake Wobegon is that all of the children are above average. Now, this may sound like an impossible statement, but again, it all depends on your point of view. If the average that you're discussing is a national average, it could be possible that Lake Wobegon's children could all be above average. We have more details on the website, so feel free to go look at those. We hope you've enjoyed working with this module. Rhonda and I had a wonderful time putting this together. We also hope you enjoyed our little song and dance at the end. That's all for your entertainment and for your enjoyment with your students. Also, if you have any curious students who are wondering, did they actually figure out what the average note was that Dan sang or the average number of taps that Rhonda tapped? We actually did. And we've got a file on the website, once again, that has the full details. So feel free to discuss that over with your students on how we did it. And again, if you have other flaws of averages that come to mind, please feel free to share them, or other examples that work out in between the two segments. Please don't hesitate to use those as well. We hope you had a wonderful time with our module. And once again, Rhonda and I had a great time putting it together. Take care and have a good day.